Good afternoon from California and welcome. I'm Jennifer DeVere Brody, the Faculty Director at the Center for Comparative Studies in Race and Ethnicity at Stanford University. This event is part of our series on race, technology, and civil society. Today, we're going to be focusing on tools for combating bias in data sets and models. Indeed, we're going to be questioning whether combating bias is sufficient to make serious change. Before we get started with the actual program, and we're very excited about our guests today, I want to show a short video acknowledging that Stanford sits on the unceded land of the Muwekma Ohlone. Thank you.
Stanford sits on the territory of Huichin, the ancestral and unceded lands of the Muwekma Ohlone tribe,
who are the successors of the historic and sovereign Verona Band of Alameda County. This land was, and continues to be, of great importance to Native people.
We recognize that every member of the community has benefited
and continues to benefit from the use and occupation of this land.
Consistent with our values of community and diversity,
we have a responsibility
to
acknowledge and make visible
the university's relationship to Native people.
We want to thank our partners in the series, the Stanford Digital Civil Society Lab, Stanford Institute for Human-Centered AI, and the Public Interest Technology University Network. Stay tuned for future events in the series. Now, I'd like to introduce the moderator for today's panel, Hong Chu. Hong is a race and technology practitioner fellow here at the center. He was one of the earliest engineers at YouTube, and as an assembly project fellow at Harvard's Berkman Klein Center, he and colleagues developed a discovery tool called AI Blind Spots that helped developers discover the risk of their work that could perpetuate unconscious biases or structural inequality. The tool assists them so that they can address these problems well before products are deployed. And we're really grateful to have Hong, who joined us in 2020 at the Center for Comparative Studies in Race and Ethnicity. Hong.
Thank you so much, Professor Brody, and welcome everyone. I want to thank the staff and especially Daniel David Murray for organizing this series, Race, Technology, and Civil Society. These are indeed critical times and critical conversations in this time of crisis. I'm very humbled to have the privilege to moderate this panel of renowned experts and leaders at the intersection of artificial intelligence and racial justice. First, I want to express my thanks to my fellowship hosts and also all my fellow practitioners who have supported me throughout this year. It's been a real awakening for me. I'm very grateful to every member of the Stanford community. So for this panel, we are a group of scholars, practitioners, and activists. And sometimes we're playing multiple roles at the same time, simultaneously. I want to give every panelist a chance to speak freely so that they can illuminate the challenges they're facing. And I'd like to begin by framing this conversation, this whole panel, to have two different definitions of what we mean by combating bias. The first version of combating bias might be to use technical tools and to quote unquote de-bias the data, de-bias the algorithms to ensure equal treatment. But that might not go far enough. We might want to go beyond technical de-biasing to strive for equity in the historical and cultural context of white dominant culture. So these are two very different, very important distinctions to keep in mind throughout this conversation. So without further ado, I'm going to introduce each of the panelists. But before I do that, I want to tell you a quote. I want to relay a quote that's in Timnit's paper on the dangers of stochastic parrots. Can language models be too big? And this quote, I think, really captures the essence of this whole debate. It goes like this. Feeding AI systems on the world's beauty, ugliness, and cruelty, but expecting it to reflect only the beauty, it's a fantasy. So that's the starting point. And with that, I'd like to give you a sense of who's on the panel. First, I'll begin with Timnit Gebru. She's a computer scientist who works on algorithmic bias and data mining. She's an advocate for diversity in technology and co-founder of Black in AI, a community of Black researchers working in artificial intelligence. She's also known for her work to investigate racial bias in facial recognition systems with Joy Polawini. Timnit is a Stanford alumnus, having received her BS and MS in electrical engineering from Stanford, as well as her PhD from the Stanford Artificial Intelligence Lab, studying under Professor Fei-Fei Li, and she graduated in 2017. So welcome, it's almost like a homecoming for you, so we're really excited to have you back. Before we go into each person's introductory remarks, I'll quickly redo everyone. So the next person on the panel is Michael Heim. He's a distinguished research staff member in the IBM Research AI department. In addition, he's an ACM distinguished scientist, a member of IBM's Academy of Technology. His current research focuses on the general area of trusted AI, namely fairness, explainability, transparency, and governance of AI systems. After receiving his PhD from NYU in 1991, Michael spent 7 years as an assistant and associate professor of computer science at SUNY New Paltz. And last but not least, we have James Zhou. He's an assistant professor of biomedical data science and, by courtesy of computer science and electrical engineering at Stanford. His researches a wide variety of problems in machine learning and provides mathematical properties and proves from proving mathematical properties to building large-scale algorithms with a particular interest in applications in biotech and health. He has worked to develop new technologies that make machine learning more reliable, more robust, and more accountable to humans. James received his PhD from Harvard in 2014. So with the introduction out of the way, I want to dive straight into the opening remarks. And just to, if you need a prompt, I'd like to ask a question, just if you need any setup. The framing maybe describe your work creating tools for combating bias in data sets, and feel free to share any personal stories about institutions and adoption of these tools and how you came to the realization this is really important work, and give as many real-world examples to illustrate as you like. So please go ahead. We'll go in the order of introduction. So Timnit first, please.
Let's see. I think I first started thinking about these issues as they relate to machine learning, AI, etc. in like 2015, 2016, but as it relates to my work. So as it relates to, the presence of people in this field, I'd been thinking about it for a while. Because the moment I went to grad school, I didn't see any Black people at all. And then I was very alarmed when I started going to conferences and stuff. The numbers were really low, but the first time I thought about specifically in terms of technology and how it relates to these issues, I think it was when I saw Joy Buolamwini's TED Talk, and I believe it was in 2015, and she was kind of talking about her experience with detecting open source computer face detection tools, not detecting her face, but then when her roommate, when she had her roommate, it would detect her roommate's face, and it wouldn't detect Joy's face, but it would start detecting it if she had a white mask. And so that was sort of the first time I was thinking about that. And around the same time, I also kind of, a year or so later, I read the ProPublica article about crime recidivism rates, because I didn't know these tools were being used for that kind of stuff. So that's sort of when it all came together. And then I started connecting it to my own work, where, in my PhD thesis, I've been spending most of my time collecting data. And I kind of realized like how much work that takes, and how careful you have to be, and how many things you have to think about, how many mistakes I made in my own work. I talk about it sometimes in trying to predict certain things from or infer certain attributes from publicly available data. So all of that I feel like started coming together for me in 2016. And then the combination of, the institutional work that's required, because it's uphill and people are going to try to shut down your work. Obviously, I mean, you guys saw what happened to me. So that's always been the problem, whatever institution I've been in. And so, yeah, that's in a nutshell, sort of, I think that the first time I connected it to, I've always been, because of just who I am, my life story and whatever, I've always been attuned to the issues in real life that affect people in certain communities, because I've just been dealing with it over and over again. But connecting that to technology and all of our works, that didn't happen for me until about 2015.
Thank you so much for sharing. And I really, I think we'll dive into the tremendous contributions you made. So we'll have lots of time to talk about those. So next, maybe we can go to Michael. Please go ahead.
Thanks. I'm really excited to be here with the great panelists, and also to learn from each other and the audience. My background, as you probably guessed, is in computer science. And in the last 5 years or so, I've been looking at the space of trusted AI. I have the pleasure of working with about 30 other people, other researchers in IBM Research, that have been looking at various aspects of trusted AI. So about 3 years ago, we decided to come together and put out an open source toolkit called Fairness 360 that addresses some of the issues we're talking about here. Certainly not all the issues. We'll talk more about it later. But what we saw at the time was that there were people in the community who, like the panelists and host, who cared deeply about this topic and are writing really very good scientific papers. And of course, there was society who cared about it. But there seemed to be a gap, and this forum is one of the ways of addressing that gap, sort of bringing communities together. And then we decided to also bring them together by releasing basically a bunch of code that would capture what the scientific community has done up until that point in terms of measuring bias and quote unquote mitigating bias, which we'll get into more after. And the idea was, give people code and tools that they could use, but also to facilitate communication. So we spent a lot of time documenting what the tools do, and also having tutorials and demos, and having a Slack channel for people can discuss and ask questions, and of course improve if they want to work on the code and so on. This toolkit's turned out to be pretty popular with researchers and companies. It's being taught in some universities, and the Slack channel has 900 members for whatever that's worth. Those are people who actually go and sign up explicitly. So I invite anyone to come and join there. The next year, we decided to do something similar with the topic of explainability, which I know is not the topic of this panel. We released another toolkit, same kind of story. And that's gotten interest. There was a workshop last week, for example, that NIST ran on this very topic of explainability. And other folks in the government, congressional staffers and so on are sort of asking about, what does it mean to be explainable, and can this be useful? Is there a way of regulating this, and so on? And maybe we can get into those details later. But what I wanted to get to is the main topic, I think, for this panel is in 2018, I guess about 3 years ago, we started a project called Fact Sheets. And it was similar to other kinds of projects in this space. Basically, the community was coming together and saying, we really need greater transparency of AI models because of all the concerns about bias and other things. At the time, there was a number of folks who were saying, well, in order to get transparency, you need to show me all the code. Companies should release all their code, and then we'll have full transparency, and the problem will be solved. But unfortunately, that's not sufficient, because if I gave you 10 million lines of code, I certainly can't understand that, and it's not clear, others can understand it. And there's other issues with that as well. So what we tried to do is look at what other industries had in terms of solutions to this problem. Transparency is not unique to AI. Maybe the stakes are higher, but other industries need transparency as well. And so we looked into those other industries and tried to get inspired, and that's where we came up with this idea of a fact sheet. When we wrote the paper, we gave some examples of questions that one may answer about your AI system to make it more clear what was going on. But it really was a suggestion to start a dialogue in terms of what are the things that people care about. What people care about depends on who you are and what your concerns are. If you're a regulator, you may care about one thing. If you're a manager, you may care about another. If you're the affected human, which is a large number of people, then certainly you care about other things. So we kind of push the envelope a little to say, we don't want to say, here's the magic list of questions. If you answer these truthfully, you'll solve all of society's problems. But we really think it should be tailored to a particular use case in terms of what your model is doing or what your AI is doing, and also into who the audience is. So since then, you were asking about experiences. We worked internally with a bunch of groups within IBM and wrote a paper about the experiences with, okay, given this desire to have more transparency of how your AI system is built, how do you go about and do that? And we learned a lot, and we'll probably get into those things later on. But then there was also this question of, how do you tailor it to your particular audience? How do I understand who my audience is? Why am I doing this? And what do they need? And again, we wrote a paper about that, and there's more information on our website. So just to summarize it all up, we've created these open source toolboxes that are trying to bridge communities, and then they get sort of used in this fact sheet idea, which is a way of giving transparency. And we could talk more about this as we go on.
Thank you very much, Michael, and really appreciate your technical leadership, but more importantly, the community building you're doing, and also the leadership in contributing to this movement in AI ethics and governance. So next, let's go to James. So please go ahead and share your story.
Okay, great. It's very nice to meet all of you, and thanks Hong and Jennifer for organizing this panel. It's super exciting. So, as Hong mentioned, a lot of my research is really in developing and actually deploying AI systems, especially for health and for biomedical applications, right? And I think especially for health, because it's so salient to all of us and so important, I think it's especially important and critical to think about how do we deploy these systems so that they are fair and also accountable and really works well and benefits broader segments of society, right? Especially in low resource settings. And just to give you an example of the kinds of fairness challenges we run into here, right? So recently, we were actually building a system to improve telehealth. So as many of you probably have personal experience, right? So because of the pandemic, so the usage, the need for telehealth, which is to meet with your physicians across these kind of video visits, has really exploded in the last few months, right? And even at Stanford, I think most of the patient visits are actually through these video visits. And one of the biggest things that we run into in telehealth is actually just the quality of getting high quality images, right, from patients to clinicians. So currently how it works is that people would actually take their cell phones at home and take photos of their skin, of other parts of their, if they have some skin conditions, and then they'll send those photos to their clinicians, right? And that's actually ends up being a big bottleneck because people are, they're very good at taking photos for Instagram, but they're actually not very good at taking photos for clinical applications. So it actually turned out that many of the photos that people take are not sufficiently good quality, right, because they're too blurry or because the lighting is too bright or too dark for clinicians to actually make clinical judgments. So that ends up leading to a large number of frustrations and a lot of wasted time in these telehealth visits. Right, so we thought, okay, so this is a great application where we could try to deploy and develop some computer vision tools. And we had developed a tool to help patients to basically take better quality photos And also, if patients' photos are not sufficiently good quality, the tool actually tell the patients, you need to maybe improve the lighting, or you need to zoom in a bit more to take better photos. Right. So that's so far so good, right? But one of the big challenges we realized there is that to develop such AI tools, especially for computer vision, we do need to have quite a bit of imaging, photos, data to train and to validate such tools. And it turned out that actually especially for skin photos, right, there are actually very few existing databases, available databases of photos from darker skin individuals, right? So most of the tools that are used for the skin training algorithms for diagnosis, predictions, machine learning algorithms are actually from just lighter skin individuals. So that's actually ends up being a huge challenge for this particular algorithm, or for this technology we want to build and deploy, is that how do we really ensure that the system really works well across all the segments, all the different demographics, right? And for example, to address this particular challenge, we're actually starting the Skin of Color project, which is sort of like a citizen science project to really curate one of the largest publicly available databases, right, of photos that are medically annotated from diverse skin tones. So that project is led by a terrific postdoc, MD, PhD, Roxana in the group. But hopefully that just gives you one idea of illustration of, if we really try to deploy AI systems in practice, which is our ultimate goal, right? So what are the kinds of challenges that you run into to ensure that these systems are reliable? So that's an area that's really been motivating a lot of the work in my group. And it's actually really interesting to hear about, the story from my friend Timnit, because I actually also started to think about these problems around similar times, around 2014, 2015. So I was at Microsoft Research at that time before I moved to Stanford. I was a postdoc at Microsoft Research. And it's actually quite serendipitous because we were studying some of these earlier versions of these language models, right? So like the predecessors to like GPT-3, right? And we weren't actually even thinking about biases because that was not really on people's mind so much at the time. And that's certainly one of the blind spots that everyone had. And we were just developing little queries to basically ask, basically little puzzles to ask these language models. And one of the things that was actually very surprising to us that we discovered is that these language models actually had a lot of gender biases built into them, right? Which actually really launched this big thread of research that we've been a part of. And we extended that work to also look at, for example, the racial biases and other kinds of biases in language models and also in other kinds of models. And I know other people on this panel have done really interesting work in that area. Maybe it's one last thing I'll add about that is that I think one interesting opportunity, going back to Hong's point of, you can certainly try to debias these AI technologies, but in parallel, I think it's also been really interesting to think about how can we use these AI and biases in AI as a way to study our own human biases, right? Because one thing for example, we learned in our experience working with the biases in the language model is that it's actually really a great microscope in some sense to flip things around and study our own biases, especially in settings that's been quite difficult to quantify our stereotypes. Right? So for example, we actually look at language models that have been trained on historical data, like text data from earlier part of 20th century, to study what are the biases, right, in these writings towards like Chinese Americans, towards Asian Americans. It's a really important talk, but there was just very little quantitative data because people didn't do systematic surveys of these stereotypes. But the information is actually in the text, right? And the fact that these AI models are so good at capturing and crystallizing biases in the training data actually makes them a really useful artifact to study our own biases in the past. So I think that's potentially part of the broader connection to society. I think will be really interesting, both as challenges as well as opportunities.
Those are great examples, James, and great work you're producing for so long now. Speaking of language models, I want to just explain what they are first, and then we'll have a deep discussion on specifically these models. So one of the latest ones is called GPT-3. It has billions and trillions of training data and variables and parameters. But what you can produce is you can generate entire paragraphs and stories. And if you give it a few words, you can generate images that's associated with it. The training data sometimes is somewhat suspect. I heard in older versions, they took Reddit links and took what people are linking to out of Reddit, and they scrape the whole web. And I think Timnit, your paper really focuses on maybe some of the potential risks in that methodology. Some of your paper really, covers it quite well. And you also mentioned how do we move forward, the path forward. Could you kind of summarize, because it's a great paper and I want you to, explain all the good ideas.
That got me fired. So, well, or that's the story. It's not, I don't feel like I got fired because of the paper, but, so I think that for me, at least in my work, one of the things, I'm going to answer your question, but I just wanted to give you how I approach this kind of work. One of the things I think is really important in this work is to bring forward different people's thoughts, like different people's ideas about this, because it's impossible. So for me, I personally can't, what I think is very different from some other people, and like some of the risks I could think about, even if I look at prior work, some of the things I would focus on are very different from some of the works that other people would focus on. So one of the things that we thought it was really important was to bring to fore the thoughts and works of that other people kind of are really passionate about. So for instance, in my work with Joy, where we showed that the disparities in error rates and automated facial analysis tools, it was sort of like that, right? Like she first was working on this, and so my role was more to bring her thoughts forward. So in this work, what I was trying to do was actually when I was at Google, a lot of people were asking me these questions. What are the risks that you think about? How should we approach this? What are some of the ethical considerations when we are working on this? And like people were just so like, I don't know if the rest of you feel like this, but everybody was just so excited about the size of the language models, and that's all they were talking about. We want to make a giant model. How do we make a giant model? And I'm just like, can we slow down for a little bit? Because if all you were trying to do is just kind of rush to making larger language models, we don't even have time to think about the risks. So when people kept on asking me these questions, I would actually link to Emily Bender's tweets and Emily M. Bender's tweets. And at some point I got sick of like linking to her tweets. And so I messaged her and I said, hey, I keep on linking to your tweets when people are asking me questions. I'd rather just link to a paper. I want to just give them a citation, but I don't really think of any good ones. And if you have any good ones to recommend, maybe you can tell me. And if you don't, if you can write a paper about it, because I really kind of, value your expertise and your thoughts on this, because linguists have been kind of left out of this conversation, I feel, especially social linguists, because what I really appreciate about linguists is that they have to deal with many, many different cultures. They have to contend with issues of power and cultures and language and society, and that's the perspective that we don't have at all. So she was like, oh no, I don't have any papers that I know of, but yeah, like if you want to write one, like let's do it. And at this point, the rest of our team, the ethical AI team, who I'm so upset that their names can't be on the paper, had also been writing little documents and stuff like that. So we discussed, and so the main things we came up with were the data like that you just mentioned. Many of us, I am being harassed on Twitter right now. This guy was coming to my talks. I don't even know, he might even be here. Like, and my other talk, he asked a question just to make sure I knew he was here. His account is suspended now on Twitter, but he was like stalking me and a bunch of other people. So that's the kind of, harassment we're getting online, right? And I don't ever go on Reddit, even on things that I would find interesting, because I know that is such a toxic environment. So the moment you tell me that is something that you're using to train these models, I'm already, I already have a light bulb going. Whereas somebody else who doesn't have that experience will not have a light bulb going. So that's why it's so important to bring different groups of people's understanding to the fore. And so in that sense, we had Mark Diaz, who's a social scientist, for instance, and this was supposed to be his first paper at Google with a Google. And so he really brought the ideas about social movements. So he'd been studying, a lot of his thesis was concerned with ageism and how it manifests itself in these sentiment analyzers and things like that. So he did a lot of experiments there, both quantitative and qualitative. And so a lot of those ideas came from him. There were a lot of other ideas from psycholinguistics and et cetera that came from Emily and Meg. And so, you know, I guess I'm just saying that. And then, of course, like Ben Hutchinson and Vinod, who are our other co-authors, also, they had shown some of these biases and sentiment analyzers before, just for names, or biases in terms of people with disabilities. Like if you say, I am a man, or like versus I'm a man with a mental illness or something like that. And so you have these sentiment analyzers who already have issues, but then we're also going to try to use those to understand the biases of these large language models. So I mean, I don't know if I told you about the risks that we came up with, but I think, like, I guess what's important for me in my work is to make sure that these voices of these different groups of people come to the fore. And what's so upsetting about what happened with our paper is that it's the opposite of that, because there were these people, these VPs who don't experience any of the things we experience, who just wanted to shut down the paper. They didn't have to. If they didn't find out about it, like I just mentioned it offhand because people kept on asking me in some meeting, if they didn't find out about it, it would have been just fine. Like nothing. It's not like, you know, somebody came down, clamped on them and stuff. So I think that if I were to give just one message to everyone working in this space, it's that the first thing you should do is to try to make sure that these voices come to the fore, right? Like, and are not suppressed. So that's what I was trying to do with this work.
And I really admire, and I hope there's more people who can do this type of work in different environments. I also want to request that, James, you can speak to a real concrete example of research you did, a paper you published about persistence bias for the Muslim community. Can you describe what you saw when you analyzed these models?
Yes. So first, I just want to echo Timnit in the importance of having different voices who work together, right? And especially from different disciplines, from different domains. Like her, I've also been really very beneficial to work with people from linguistics. Like, for example, the work I'd mentioned about looking at historical biases for Asians and for other different groups. That's actually collaboration with Dan Jurovsky, who's a linguist, and also with Londa Shibinger, who's a historian. So it's really important to actually have these different disciplines come together, especially for things like thinking about accountability, fairness, and bias, because they have very different and very useful perspectives for computer scientists. Yeah, and the specific example that you mentioned about, so that was also for GPT-3 algorithm, and actually Timnit has given us some helpful feedback to that for the students. So it's really led by my PhD student, Abu Bakr, right, who's a terrific PhD student here at Stanford. And he was just playing with these models, the GPT-3 models. And one thing that he noticed is that there's actually a lot of association between Muslims and violence in these models, right? So what he would do would be, you would type in stuff like a prompt, like, for example, like, 2 Muslims, and then the model itself will actually do autocomplete, right? It would generate additional sentences. And what he was finding was that when you type in, starting with things like 2 Muslims, and then the model will actually autocomplete into all sorts of violence. Like they would say 2 Muslims would shoot, or 2 Muslims are terrorists. And even when he tried to explicitly write that 2 Muslims walked into a mosque to worship peacefully, right? So that would be the prompt, right? The model was still complete into something like that, and then they were shot, right? So I guess the thing that's quite surprising and quite disturbing to him and to other researchers is that just how persistent these biases are, right, in these large-scale language models, even when you explicitly give positive words like peaceful and worship as a part of your prompt. So I think that's really an example of the kinds of stereotypes and negative associations that are picked up in these large-scale language models, precisely because of the kinds of data they were trained on.
Yeah, that's really a very, a vivid example. Now I'd like to try to see how industry is using these models and these tools as foundational machine learning, natural language processing databases and models. So maybe Michael, you said that fact sheets vary based on the communication purpose and audience, and you believe that a single standard fact sheet that for all use cases is not feasible because of the context, industry domain, and target consumers will determine the facts that's needed and how they should be used. I think you're at the front line, so please share with us your strategies for mitigating these risks.
Sure. So what we found is that when you talk about sort of transparency and what information people want to know about a model, or even more generally about an AI system, who they are in terms of the role they play will probably have a big indication on what they care about. So I'll give you a few examples, not in the order of importance probably. The first one would be within the construction of an AI system, there's usually a role that's kind of a quality assurance role or a validation role. They often call it a model validator. This is very popular in financial institutions because it's required by law. And they're supposed to be an independent person who will take a model that a data scientist produces and will check for risks. And risk can come in many different flavors. Sometimes the risks are the model is maybe a deep neural network and it has 100 features, and that's just risky in itself. And so they'll try and poke at it and try to see if it could be done in a simpler way and check for other things as well. That kind of person would like to have a lot of detailed information about the training data set, what transformations were performed, what algorithm was used, and so on. Another role you may have is a regulator who's coming in and maybe auditing a company and saying, hey, I'd like to know why, show me your processes, show me how you deal with risk, convince me that you're doing things the right way. And then probably more important, particularly to this crowd, is the importance of the end user, right? Or the affected user, right? So let's take a scenario where there's a physician who's looking at an image and they're finding out, they're going to use the image to detect cancer or not. They would like to know something about that model before they use it. What was it trained on, as we talked about? What were the demographics in the data set, and so on. So they want to know different kinds of information. And so our feeling is the fact sheet needs to be tailored to each of these particular users to find out what they care about. And in fact, on our website, we have a methodology, not a magic tool, but a bunch of steps that people can go through to figure out what kind of information is needed by doing sort of the obvious things, talking to that target audience, identify who the audience is, and understand what they need, and then go back to the generator of the model and figure out, can you produce this information? And if you can't, then maybe there's an issue in having this model be deployed, and so on. So it's not an easy answer, as I think everyone would probably expect, is that you need to really think. I totally echo what others have said about having multiple disciplines and multiple stakeholders at the table to get this feedback loop about what we care about. It's not simply a data scientist has an idea, starts building a model, it looks like it has good accuracy, and we deploy it. It's much more sophisticated and complex than that, particularly in high-stake domains.
And so thank you for that. I'd like to kind of spice up the debate and challenge you all by putting out this quote from, I think, Timnit's colleague and co-author, Deborah Raji. She said, there is no future version of data that is magically unbiased. Data will always be subjective interpretation of someone's reality, a specific representation of the goals and perspectives we choose to prioritize. It's about power held by those of us responsible for sourcing, selecting, designing this data, and developing models to interpret that information. I'll throw the floor open. Whoever wants to react to that quote, please go jump in.
I mean, I can say a little bit. I agree with that quote. I don't know what else. Debs is my collaborator, and actually we wrote this other paper where she wrote about procedural fairness. I really like this idea of procedural fairness because it's about how you get to the, you know, it's not necessarily like about the definition, but how you, so let's say people say, you know, maybe we should have tests to see if this model passed this test, it should be launched. If it doesn't, then it doesn't. It's not launched, something like that. How do you do that test? Who does that test? Who is involved in the process? I think that's that's the most important part to focus on, right? Let's say plenty of people can write about the risks and harms related to large language models. Like, I believe, James, I'm not sure if the recent article on 1.0 was about this paper, about your paper that you wrote, but like David, I forgot how to say his last name. He wrote an article about this work. I think it's the work that you just mentioned. And he said, you know, okay, sure, sure that the data, the bias, the anti-Muslim bent of GPT-3 is based on the training data, but what about the bias of the people who decided that it was okay to you know, make it available and make money off of it, even though this is the model's behavior, right? So what about that? Like, that's, so you can have all sorts of tests that you want, you can have whatever you want, but like, if the right people are not at the table making these decisions, we're not going to achieve any sort of, I don't think we're going to make progress. So we see this in, you know, at Google, they have all these ethics boards and blah, 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 and this and that. And, you know, watch what happened, right? And so that's because, you know, sure, they don't have procedure, what I call, or what, not what I call, but what Deb was mentioning to as procedural fairness. I also think the other thing is, so sure, now that we know there's no such thing as unbiased data, where do we go from here? It's like, what I've learned is that I think there's a huge disciplinary issue with computer science, where if you point out problems, you have to figure out the solutions right now. I mean, like, that's not, you know, there is a problem and we all have to figure out like how to move forward. And so some criticisms that we received on our paper, it was like, oh my God, this paper is an attack and you're saying this, that. I mean, you first have to figure out the problems, and then you can start working on potential ways forward. Some issues might just be like tensions. You have to weigh the costs and benefits and figure out what the costs are and what the benefits are. But so Mark Diaz, who I keep on coming back to because I'm so mad his name was not on this paper. He works on, so I think his specialty is in standpoint theory as a social scientist. And so like, you know, just the fact that there is everybody's, that whatever you do is from some point of view, right? Rather than like whatever we've been learning in school, which they call the view from nowhere, which is if it's like, you know, some objective reality. And so what he works on is then some ideas he has is then, okay, when you're trying to curate data, and you are working with certain groups of people to annotate this data, how do you then work with them to imbue certain values into that data? Because you can't, there's no such thing as unbiased. So how can you like make your values explicit and then perhaps work with certain groups of people to have a curate data with those specific values? That's a research direction he's pursuing. But I think at the very minimal thing that we need to do is understand that every single thing we do has a value judgment on it. And one of a really good paper I read on this recently was when we were doing work on COVID forecasting and some of the issues that arise there. I found this paper, I think it's called The Implicit Value Judgments in Healthcare Inequity, or something. I'm going to look it up when everybody else is talking, but they were going through case studies and they were looking at very, you know, specific things like using absolute values versus not, using precincts or states or districts for your unit area versus something else, looking at ratios versus differences. And they were talking about what implicit judgments you're making when you're just choosing these metrics, these specific metrics. And so what they say is there's no solution. You just you first have to just make your values explicit, right? And so we have this quote in our paper where, you know, words meaning change meaning depending on what who says them, and there's no cure. So there could be like, no cure for some things, but it doesn't mean that we shouldn't put out like the problems out there and then work on potential ways forward.
I think some of the, and I really appreciate your thoughts. I think some of the questions coming in are asking about how do we really make change on the corporate level, companies that's making these decisions, producing these products. And I feel like both Michael and James, you guys are also very much working closely with industry. Some of your models and your tools are being used as of today. Do you have any thoughts on, like, should we take the model cards? Should we take some data nutrition labels? How do we really operationalize and emphasize the importance of doing this work, that educating technologists that they're making value judgments and they have to document and be transparent to be responsible and have accountability for their work?
Yeah, I would say that, that what Timnit was talking about is incredibly important, identifying problems. Like if the work of people on this panel and others in the last few years hadn't happened, that the whole, FACT community and other communities like that, or ProPublica and so on, then, there wouldn't be we wouldn't be where we are now, which is not a great spot, certainly, but it'd be much, much worse. So raising awareness is incredibly important, identifying problems and then having hopefully ethical people trying to solve them is great. When I talk with customers, there is certainly an awareness, and I believe there is a concern. Some of it comes from just being decent human beings and saying we don't want to live in a society like that. Some of it comes from their role in the enterprise, where they're saying, I don't want to have headlines about my company for doing something bad. There's been many of those. And some of it is actually different. It's basically saying, I started doing AI and I did it as an experiment. And I read all the good things about what it can do, how it could be maybe more accurate or maybe save resources. And that was good. And now I have it in all different parts of my enterprise, and I need to have better control. I need to have governance, and there's governance on many different levels here. Because I just want to learn the best practices, sort of similar to maybe 30 years ago when general software was in the same place, where we needed sort of software governance. We needed a CIO basically to say, as an enterprise, this is the way we do things. We need to test things and so on. Here, the stakes are much, much higher, of course, because we don't know what the AI system is going to do ahead of time. And we may not even understand why it's doing what it's doing. So the governance is even more important. So what I'm seeing is more and more companies are, the reason I'm talking to so many companies as a researcher is because they care a lot about this space. Certainly we're not where we need to be, but I'm seeing progress and interest there. And I guess another thing is, it's not just the companies, right? And companies hopefully will do the right thing. There's also the regulation and legislation. And I'm seeing a lot going on there in the EU or in the US. Various states have passed legislation, and I'll just name one because I think it's interesting. There was a lot of concern about video interviews. I mean, there still is concern about video interviews, where an applicant is recorded, and then an AI system will magically score somehow the video based on whatever, a very scary thing. And the state of Illinois passed a law, this was last year, saying if a company is going to do this, they need to do a certain number of things. One of them is tell the applicant, which is bare minimum. The second one was the AI should explain how it works. I'm sorry, that the company should explain how the AI system works. And that was it. Those were the words. And as a citizen, I feel pretty good. As a scientist who's trying to solve that problem, trying to say, okay, here it is. Here's the explanation. I have no idea if I've satisfied the legislation or not. So, it's a step. It's the right step. But I think to really reap the benefits of the scientist community, we need to kind of get as precise as we can. Like even we're talking about bias, how do you get rid of bias? Could we define what that is in something that, you know, scientists can kind of try and tackle with social justice reformers and so on?
I'm also reading through the questions, and Michael, I think the next logical question is, there's discrimination, there's prejudice, and there's bias even among human judgment, like judges and doctors, and sometimes they treat people very differently. I think I would like to see if Professor Zhou, you have any thoughts on algorithms being biased, and especially your paper on Nature about algorithms being sexist and racist, and how humans sometimes are racist, and compare and contrast the kind of potential for lock-in of those biases.
Yeah, so that's a very interesting question. And of course, the challenge here is that for many of these, for many of the decisions, it's actually comes down to value judgments and sort of normative positions, right? And that's where actually it's often hard to say, here's really objectively the best thing you can do, right? Here's objectively the fair way to allocate vaccines or allocate credits. And that's where I think a lot of the potential tension between sort of humans' biases and their own different values come in contact with the different implicit biases and values from algorithms. So you asked about, operationally, so how do we really improve things, right, in the face of these kind of tensions and difficulties? I mean, I think, like Michael mentioned, I think it is quite important to try to be as transparent as possible, right? So it's certainly as settings, many of these applications, it's important for users, right, for the customers, for the patients who are potentially being affected by these algorithms, to know when is the algorithm coming to play, right, and when is the human decision coming to play. Oftentimes, it's some combination of the two, right? So it'd be important to really highlight those examples and make that as transparent as possible, right? I mean, I think the other part is to really appreciate that there are these competing objectives, right, oftentimes that are conflict with each other, and to move towards a setting where the algorithms, right, are also being evaluated along not just one objective, but along a spectrum of different objectives, right? There's often a trend in standard machine learning. That's something that we also teach in school, is that, for standard machine learning, you pick an objective. Maybe you want to minimize loss on this population, or you want to maximize accuracy. You pick your favorite objective, and then you just try to optimize for that objective, right? And I think maybe a lot of the challenges we're seeing now is the inappropriate choice of this particular optimization objective that people end up picking, right? Together with certainly the other issues about the biases in the procedure and the biases in the data. Something that operationally that I think would be quite useful is to, instead of move away from that mentality of just picking one objective to optimize, but really think about how do we evaluate a given algorithm and a given prediction along a whole spectrum of diverse objectives, right? For example, even a simple thing is like, instead of saying, how well does the algorithm work? What is its accuracy on the whole population? You can see, okay, so what is its accuracy on different demographic subgroups, right? So that it's very simple, but already itself will tell you some differences of potential disparities, right? So I think these are potentially some approaches towards really addressing this sort of really underlying tension, which arises from fundamentally the fact that that the humans themselves have our own biases and conflicting normative values.
Thank you so much, Professor Zhou, for your insightful explanation on both the technical level, but also on the societal human level. In my research, I often, in the AI blind spots model, point to the success criteria. What is the success criteria the team is setting for itself? But even a higher level up is what Professor Wuha Benjamin would say, how are you formulating the problem? If you're formulating the purpose and goal in a way that maybe it's about profit maximization, then that's already moving away from equity and trying to address the systemic racism issues that we're facing. And you might, organizations might not even be aware. For me, I believe it's more pernicious to be passively complicit than even to be intentionally malicious. So that's one of the reasons I kind of left Silicon Valley, left the tech companies, and work in now in research. But I'd love to hear Timnit's notion. You in your paper mentioned the term value-sensitive design. Can you elaborate on what you mean by value-sensitive design?
So this is, I guess, it's not, I don't, I'm not an expert in value sensitive design, but this is a notion that people have in human computer interaction, for instance, where, but like some of the stuff I talked about with Mark, for instance, where kind of explicitly thinking about your values and how to imbue them in the products that you're making and coming up with a process around it. So for instance, I know Batya Friedman has written a book, I believe, on it. And Batya Friedman also is the co-author of Emily Bender on their data statements for NLP paper. So that's just one of the examples. And they have some processes to like participatory design processes to incorporate many different perspectives. So out of all the different, computer science disciplines, I feel like HCI, I'm hanging out a lot more with people in HCI just because I like them better. I'm just like, I can actually, I don't know, so yeah, so that's what I'm learning from people in HCI. And I'm sure other people have a better understanding of this. And I was reading somebody's comment on the chat about bringing different perspectives to the fore, because I mean, this is again the justice oriented work that we need to do, or the power imbalances that we just need to understand and fight when we're working on these things, because I think if we don't do that, I don't care like how well intentioned people are, we're not going to get to the right place. So one example is there was this work on, I don't remember, it was like some work on synthesizing someone's face based on their voice, or vice versa. I don't remember the exact work, but Alex Hanna, who was in our team, I mean, my former team, looked at this work and was just like, this is so transphobic. Immediately, and was just like writing down all, and this was at NeurIPS, and other people had, very well-known people had lines and lines of work along this, and they didn't even think about it, right? Like they've never thought about being transphobic or being in the trans community. This is not something they've ever had to think about. They're not incentivized to think about it. There's no punishment for, I mean, there's just no reason for them to interact with this, with this kind of harm that they might cause. And even if they want to, if they don't have input from people in that community, how are they going to even know that this is a problem? But even when they know that this is a problem, they might not think this is a priority. And there's nothing that makes them feel like this is a priority. So she called it out, and then she spent the time to go talk to people working in this space, have a meeting about it, explain, ask for their perspective. Imagine how many times she has to do, like, this is extra work that we all have to do, right? And that's the good outcome. That's when things go well. When things don't go well, you try to do that and then you still get fired, because there's no reason for people to have to interact with that kind of situation. So again, like, there are some very simple things, in my opinion, that need to be done before we even think about, any sort of debiasing mechanisms or whatever. That is, bring the perspectives of people from the most marginalized communities to the fore.
I completely agree. And I'd like to give a concrete example again. The campus algorithm, when it decides who to allow to bail or not to accept bail and leave the jail, the prisons. There's a professor at Harvard Kennedy School, Sandra Susan, and she has studied the effect on people's lives when they have to stay in jail for one day, whether it's job loss or impact on reputation. It is very devastating. So whoever's working on those tools, they're really impacting the lived experiences of these individuals. And this professor is Sandra Susan Smith. Look up her work on the sociology of that type of experience. But I also want to from here try to see what can industry do? How can we make tools that focus on equity to try to not just equalize, but to maybe compensate for the historical legacy of systemic racism that we're still dealing with today? How might we think about affirmative action algorithms that Professor David Ho and Alice Sham has written about at HAI? If I can throw it to maybe Michael or Professor Zhou, if there was affirmative action type of decisions that was made, how would your tools, accept that or operationalize that?
Yeah, so I could take a first crack. So the way the Fairness 360 tool works, and this is really, again, a collection of what the community has done. It's not just, it's certainly not me at all. But it's basically a way of measuring bias in a data set. So just make it very simple. Let's say we're doing loan approval. It's basically doing math. It's saying, okay, in your training data set, let's look at potential bias on gender. And we'll look at each of the groups and we'll see what the approval rate is for each of those groups in your training data. Okay, and if it looks like one is greater than another, then you seem to have a bias for or against one of those groups. So nothing very deep there, just it's basically doing that calculation. What's important for that is someone, and this is where it gets to the multi-stakeholder aspect, someone needs to say, which of these features am I looking at? And how should I measure bias? There's a great talk that was at the FactStar conference a few years ago talking about 21 different ways of measuring bias. And I encourage people to look at that talk because there's not a simple answer. And so the first question is, which features in the data set do you want to look for bias? The next question is, what metric do you want to use to measure bias for that feature? And then getting back to your question, once you have that value, what is good and what is bad, right? So for example, some of the metrics have a 0 as being perfectly fair, meaning they have the same rate in my example, and numbers more towards 1 would be biased in one direction and -1 would be biased in the other direction. And what you can do is you can say, well, who's the historically disadvantaged group, and do sort of an affirmative action, like you said, let's say we make sure we have that there. So it's all math in the end, what these tools do. But as I think everyone realizes, this is not sufficient. There's a lot of important conversations that certainly not a data scientist or an engineer should be deciding. You need to have people figure out, what features am I talking about? What is from a societal point of view, what's the right way of measuring? And just one more thing I want to mention is when we talk about bias, there's a not societal bias. Think of mathematical bias for a second. The way machine learning works is it's trying to look for patterns in the data, right? So take another somewhat silly example. Let's say I have the same loan approval, and it turns out that the same tool could be used to find out if there's a bias on salary. Is it the case that higher salaried people tend to get approved for loans more often than lower salaried people, right? Probably it'll be the answer to that will probably be yes. And most of us, I think, would probably say that's reasonable. Maybe it's a good sign of creditworthiness. I know there's a lot more involved there, but and so bias from a mathematical sense is kind of the technique that the machine learning is using, not the way we're using it in this thing. So when you get down to sort of the plumbing here, you've got to figure out which biases, which features are bad. Some of those are regulated. There's laws about them. Some of them, just, we have to catch up to the laws have to catch up to us. We need to be more proactive on. And then those are the ones that you can measure.
Thank you, Michael. And me working as a lecturer in a public policy school, I'm so glad one engineer, at least in the world, admits it takes policymakers and governance and participation in the community to make those whatever you call it, variables, constants, weights. And so I think some of the questions that's coming in is about cultural context and historical context. We realize we're not ahistorical, we're not writing equations in the face of perfect equality, and we just need to fine tune everything. And we're not ahistorical, but we also have to understand the cultural context. And I think Professor Zhou, you have written in Nature, your paper, about how many images are sourced just from a very US-centric perspective. Could you share some of your findings there?
Yeah, so that's a great question. I do want to say a little bit about the previous point as well, because I think that's very important about, practically from a company's perspective, what are some of the things that they could operationalize and they could do, right? I think one thing is worth emphasizing is just, I think, a relatively low-hanging fruit from the company's perspective is actually just to do more rigorous testing of their AI algorithm across multiple objectives, across multiple subgroups, right? So that is relatively straightforward to do, but it's actually a bit surprising to us that it's not being done by many of the AI developers before the AI systems are being deployed. Just to give you a very concrete example, with a couple of students, so we actually recently just looked through all of the medical AI algorithms that were approved by the FDA. So these are already approved by the FDA, so they can be used on patients. There's 100 plus of them. And we specifically actually looked at how is each one actually evaluated before they were approved by the FDA. And it was actually quite surprising to us. It might be surprising to all of you that many of them were actually only evaluated at one site, right, at one hospital. Right? And many of them do not actually report how well did this algorithm work across different demographic groups, right? By gender, by age, right, by ethnic groups. Right? Now the companies might have that data, right? Maybe they do have this data internally, but I think even just making sure that those are the kinds of data that are being systematically being reported, right, or being used to evaluate the algorithm before they're being deployed would be a relatively low bar to do, right? But I think that would already make things much better in practice, right? And again, these medical AI devices, I think relatively few of them are actually even are doing that. Right? And this also ties in a little bit with your with sort of the historical context you're asking, right? Because I think a part of this reason why, for example, many of these medical AI algorithms are not doing such rigorous testing evaluation is because some of them maybe were following testing evaluation procedures from earlier periods, like before the deep learning and before the modern AI advances. Right? And this is where maybe it's fine if you have like a particular, let's say, a physics-based simulator, right? The way that you test and evaluate that may not be sufficient for testing and evaluating the data-driven AI systems, right? Just because we know that the AI systems have its own strengths and weaknesses. For example, they tend to work less well on when you diverge from the training data, right? So I think that's where it is really important to understand, okay, so the regulations for the FDA in place, right, for evaluating these AI systems were coming from, maybe drawing from their experiences with some of these pre-AI devices, right? But then understanding, okay, those may not be sufficient for evaluating the modern AI systems.
Thank you. And I'd like to read one of the quotes you wrote in your article, that our societies have long endured inequalities. AI must not unintentionally sustain or worsen them. So that's from Professor James Zhou in his Nature paper. So that brings us to the next very important question of, we always frame that, we need more digital literacy. We need to get people to understand the technology. But I asked the question in reverse: how do we increase racial literacy in the tech industry? And there's a research paper published by my fellow at Stanford, Mutali, on advancing racial literacy in tech. So everyone should read that. But I'm kind of preaching to the choir. If you're here, you kind of care about it. But how do we reach the millions of other engineers out there working on these systems? Do you have any ideas on how to,
Oh, because I tried to do it and I got fired, so I'm not exactly sure what. Mutali's paper, we shared it very heavily at Google. I think she wrote it when she was at Data and Society, if I'm not mistaken. And I mean, let me tell you, like we had just, that was night and day what we were doing. We wrote a document called, I believe it was called like Urgency Not Understood. And we were trying to increase racial literacy within the people who are working on ML fairness at Google, or responsible AI, whatever you want to call it. Because we were just getting so frustrated with that group of people. Like the Black people were just sitting there and be like, okay, you're working on this area, you're working in this field, and you don't seem to have racial literacy. Let's try this. So we wrote a document, we met with people, all the staff, and then there's a lot of high turnover in the people working on diversity too, because they don't have, within research at least, they don't have any power. They try to actually give real feedback. When they give real feedback, they're relegated to something, they're, miserable, they leave. So I guess what I want is, there's just no way that this will work if there's no incentive to change. If you have a cost benefit analysis and your cost benefit analysis says these people are creating too much of a wave and we're just better off getting rid of them and continuing as normal, like I don't see, we have enough resources. There is absolutely no shortage of resources, let me tell you. And it's really not hard to make change. In our team, we made change. When we were given the resources, we had a diverse group of people. People felt safe. There were a lot of people who were going to leave the tech industry who came to our team and would have left the industry as a whole if they didn't leave. But the thing is, that's not valued enough. And so the thing I want to talk about is, what is the incentive? How can we incentivize people in institutions to do this? Right now, I just saw there was a $5 million fine for Google. And that's like for 5,000 people, right? Like $500 per person or something. $5 million fine for Google. Is that a fine? That's like a cost, that's a line item in your cost of business. So we can talk by the way, this was also my email that got me fired, apparently. Like, that's what I said. We can write all the documents we want about how to do this, how to do that. If there is no accountability, we're not going to go anywhere, right? And so I think we need to move forward in terms of like, how can we hold institutions and people accountable?
Thank you so much. And I definitely, I cannot sympathize enough. And all the audience members express really like I appreciate your openness and hope you can, carry on the fight. I also want to read this quote from Professor Wuhad Benjamin again. I think we, owe her a lot to draw from her wisdom. It is vital to develop tools and move from assessing individual risks to evaluating the production of the risks by institutions, so that ultimately the public can hold them accountable for harmful outcomes. It's really shining the light upwards toward the institutions that we have today. And I know, Michael, you emphasize that it's a multi-stakeholder process with different relevant parties and including regulators. If there was some regulation, just off the top of your head that we should pass, some low-hanging fruit, we can make things better, maybe draw like a low watermark, you can't go below. Do you have any ideas around that?
Good question, but I'm going to give probably a disappointing answer. I'm definitely not qualified to talk about what regulations are. I'll give you an example. Earlier, I talked about the state of Illinois' regulation on video interviews, and I expressed some dissatisfaction in that it wasn't precise enough. And there was a similar thing in GDPR. There's a clause that's been written a lot about, talking about the right to an explanation in GDPR from many years ago. And the person who wrote it was visiting IBM a few years ago, and I said, and it was basically said, a citizen has a right to a meaningful explanation. And putting my scientist hat on, I went to him after the talk and I said, what do you mean by meaningful? Could you help me define that so that I can try to solve that problem and produce that? the answer I got was no, it'll get worked out over time. And then I spoke to a public policy colleague about that. I expressed my frustration, and he actually said, no, this is the way it works. And this is I didn't know a lot about this, that you write these laws to last for many, many years. And they need to be flexible enough to evolve as society evolves, and the courts kind of decide what it means, and so on and so forth. So I started this out by saying I'm not qualified. After that explanation, I'm definitely not qualified, because I want something very precise and crisp. And it doesn't seem like that's what happens with regulation.
Well, I'd like to throw this question, a variation on this question, to everyone in the panel. Are there certain AI models, AI data sets, or applications of AI for decision making that you personally just feel it's abhorrent, it should never be used for this context or this particular, to be acted upon people in this way that violates human dignity? Can you, share some of your personal opinions around that?
Sorry, did you ask me?
Anyone? No, please. Anyone,
I just got I got distracted because I saw Mutali on Twitter.
Well, I can re-ask the question if you didn't hear the.
I just got so mad again. Sorry. After saying what I was saying before, that's my day, right? Those are my days right now. I do stuff, I do things, and then I remember specific instances like this thing about racial literacy and how many times and then I get mad again. So sorry, I got distracted.
I think the simplest way to phrase it is some places where AI shouldn't be used at all, and facial recognition being prime candidate. But what determines your threshold for saying this is not at all good for AI?
I usually say that it's very difficult for me to make general statements. But when I see something, I can tell, right? So for instance, it's very hard for me to say, what is fairness? I don't know, but when I see something that's unfair, unfairness is easier to spot for me, right? So for instance, Michael was talking about video analysis on employment. And so HireVue was one company that was doing this. And then we recently I at least got a press release from them saying that they stopped doing this video analysis. They did not mention the Illinois law. They said that they stopped doing video analysis because they found that it didn't really change their results or add to their results or something. But so in my talks, I used to talk about it all the time. And I used to ask people, did you know that they were doing emotion detection on you and they were running certain softwares? And I didn't even know, because the way I found out was I was on some other random panel and I talked to the founder of Affectiva, who said that they had a partnership with them. So I kind of tried to put two and two together, right? I mean, that is clearly wrong to me. It's just like, that is wrong. Why? First of all, I don't believe that you can infer someone's internal state using computer vision. It's not magic. This is not magic, right? So even if you can, maybe you can tell that I'm smiling, but now you're going to try to infer whether I'm happy or not. And so I don't think you can do it. And secondly, even if you can do it, should you? This is a huge privacy, so let's say you can read my thoughts. Should you do that, right? Like at a job interview. Now we're going to some other territory that we're not prepared for at all. So this is just one example for me where it's kind of clear because I'm seeing the example. Other examples, I think I had to be educated. I had to learn from other people. Sorry, my dog is like playing with a toy, and she just decided like this toy, she loves this toy, and I need to get it away from her. But so other things are harder. Like, so believe it or not, for me, automated facial analysis tools, I learned from other people, other experts in advocacy, in policy, like people like Stop LAPD Spying, or other groups of people, even when I was working with Joy. Sorry, I got rid of it. I learned about it because the reason is that I was more focused on a general framework, which is let's say you look at disparities in error rates in any system. Let's say it's a melanoma detection system that where you think that it should work if we're going to use it. And so the disparity in error rates is a problem. Let's say other stuff. So in a general framework. So how do we show that these disparities exist? Now, the intricacies with automated facial analysis tools, just face recognition itself, I had to actually read and learn from other people, including the Center for Privacy and Equality at Georgetown Law. The reason being that when you look at face recognition, people make the argument, and you can't make the argument, people recognize faces, like what's the problem, right? Like, it's not a bomb, like what's the problem? So sometimes it might be very difficult to actually do this analysis, right? So you have to learn from other people for whom it's very, very clear. So I guess my answer here is that, I can't always point it out and say it shouldn't be used in X, but as a general rule, but when I see it and when you interact with a lot of people who have been studying this specific phenomena for a while, then you learn from them why something shouldn't be used in a specific way.
Thank you. And it's good to get a sense of your line of thinking. I know, Michael, you work at IBM, but I'm sure you're not intimately involved in the banning of using the facial recognition tool at IBM. But do you have any visibility, any thoughts on how corporations have banned their facial recognition tools and why, maybe even on the technical level, why they did so? Could you add to this?
You're right. I don't have visibility to that, unfortunately. So there's not much I can really add, except for what you said, that IBM decided to completely get out of this business.
Okay,
I think, yeah, someone was talking about the pluses and minuses, and I think that's certainly a part of the equation. That was a pretty big negative, from my understanding, just from the outside.
And maybe Professor, so you can also help us understand generally how image recognition, some of the biases, especially relating to diagnoses, and the pros and cons and risks there.
Yeah, so I think this is also quite closely related to your question before of when should AI not be used, right? I would say probably given the current technologies, maybe it's good to say, okay, if it's a really critical scenario, right, that could directly affect someone's safety or health outcome, then maybe AI, it's not a good idea for AI to be like the sole decision maker in that context, right? So for example, a lot of the kinds of the AI technologies that people are developing in healthcare medical settings are more as AI as like a second reader, right? So maybe it will automate some part of the process, but will provide additional information or additional feedback, but still the end results has to be made holistically by the clinician. Right, so that's probably one kind of settings where you don't want the AI to be the only decision maker that affects the patient's safety and outcome.
Great, that's really interesting. I want to ask actually one more technical question along these lines. When it comes to training data, the trend has been if we throw as much data as we can, the model gets better. That's been the kind of status quo. But now we're thinking a lot about small data sets and how to utilize smaller data sets for a variety of reasons. And especially for people of color, we often are the outliers. The model hasn't really truly accounted for this subpopulations. And as a result, we get miscategorized. Have you seen any innovation along these lines of small data and being more fair working with segments of the population?
Yeah, I can quickly add one thing, and also love to hear what other panelists think. I mean, so especially for the small populations, I think there's been some quite interesting developments called like multi-accuracy or multi-calibration, right, which is related to the idea I mentioned before of you really want to evaluate how well the algorithm works, not just on the overall population, really, but across the different segments. Right? For example, for multi-calibration, you want to be sure that the algorithm is actually giving you calibrated predictions, not just for the entire majority population, but also even for the minority groups that could be outliers, right? So I think those are some good technical approaches to think about how do we make the evaluation of AI systems more holistic and more rigorous, especially to consider potentially the minority, these, as you said, the smaller groups.
Thank you. Anyone else?
Oh,
yeah.
go ahead.
No, go ahead.
You go ahead, please.
I was just going to say that I think sometimes when we think about the problem, we kind of have things backwards. And the problem I'm talking about here is how do we get data to feed into the machine learning algorithm, right? So if we take a big step back, and I was trying to explain to my mom how machine learning works and why is it good, I would say, well, in the old days, we used to program systems. Nowadays, we don't have to explicitly program them. We kind of teach them like we teach a child in school. And then the next question is, well, okay, what do you teach them? What we found out is that teaching is hard. In this case, the analogy is getting a representative data set. That is hard. And so what people do is say, well, I've got all this data I have from historical events, and let me just use that. And that's where I think there's where the problems arise. And so in a maybe not real world, what I would like to see is people be much more conscious on the data set. Do you really want to pick up the historical data set and whatever's baked into that and use that? Or could you be more proactive and think about what are the kind of customers or whatever it is, the kind of people you're trying to serve? What are the demographics? And construct a data set or think about it. And that's really hard to do and maybe not even practical. So that's the bind I think that we're in. Another way of addressing this is if your training data set is not representative, don't make any claims about your model being representative, right? If you trained it on white males and you got accuracy of 90%, say it is 90% on white males. Don't say it's 90% on all people. Just be accurate in terms of what you've done.
I was just gonna say that so I think at every step of the way, we shouldn't pretend that like things are not political or whatever. That's another thing. It's my paper, all the words that I'm hearing from people about my work, right? It's, it's I think they're at the root of it is how we teach scientists and engineers on what science is and what engineering is and what math is, what data-driven systems are. And I like somebody linked that paper that I talked about in healthcare inequities and how they give some case studies, right? So for instance, when you talk about, I guess there's many examples, but like predictive policing is one example. A lot of companies, I found out when I was at Microsoft that Microsoft had some sort of partnership with NYPD that came out that I found out about in 2013 or something. And here I am giving talks about predictive policing. And I'm like, what? I didn't know you guys had, had this partnership. What is it, right? If it, for any Black person in the United States who has had experiences with police, you would understand why predictive policing would be an issue. And William Isaac and Christian Lum had this great paper, I think, that showed very clearly, and I think it helped with LAPD not using PredPol anymore, along with active people like, the Stop LAPD Spying. Because if you look at what data they use, it is who got arrested, not who committed a crime. We know that even if people use drugs at the same rates, who's going to be, overly policed and arrested. They showed like some of this data, they reverse engineered it, et cetera, et cetera. Now, in my lab at Stanford, when I was a PhD student, just making that statement that people get arrested at higher rates, like Black people get arrested at higher rates for, even though people use drugs at the same rate, that was controversial. That was a controversial statement. I would argue with people working in AI on that statement. So then those are the people who are going to go make decisions about data sets and curation and whatever, right? but they don't have to think of themselves as political, right? Like the same as the dominant race never has to think of themselves as racialized. The dominant gender never has to think of themselves as, of their gender. The dominant ethnicity does not have to politicize whatever their ethnicity. Then when that's a big part of your life, it's politicized, because that's just how it is. And so unless we kind of drill it in, that is how engineering and science and data-driven systems work, I don't think we're going to get into I don't think we're going to make progress, right? Because so these issues of power imbalance, racism, and justice, they're there, right? So, and I've seen it in my own experience in grad school, how I remember, like, I was talking to this guy who's now director of AI at Tesla, right? Andre, I remember this conversation where I was explaining to him how I called the police to help my friend who was getting attacked by people, and she was getting strangled like this, and we called the police. It was a whole thing. I mean, it's a long story. They ended up putting handcuffs on her. They put handcuffs on my friend who got attacked, that we called the police to help. That's the police in San Francisco for us. And I'm in this conversation, and he says, "Oh, she must have been acting crazy. She must have been, would you say that about your sister?" This is a director of AI at Tesla now, right? So that's, but he never I remember this conversation. He doesn't have to remember this conversation. This conversation is irrelevant for him. It's not relevant to his life. So, I mean, so these are the things I want people to, confront when they're learning about data-driven systems, and when they're being taught these kind of systems. So I'm really happy that, for instance, Nikki Washington has a great class at Duke that goes through, surveillance and technology and history. I know Ruha has a book, not a book, she has multiple, but a class at Princeton that she just had. And that's the kind of class I want to see at Stanford too.
Thank you so much, Timnit, for sharing these vivid personal stories. And I really think that summarizes, and it's a great way to conclude and close what we talked about today. The problem really has deep roots. It's not just in the data and getting better data. I would specifically advocate for all of us to go out. Our action item is to think about how can we educate our fellow technologists and those in positions of power to recognize the painful historical legacies and harmful racial inequalities that Black, Indigenous, people of color experience in their everyday lives, and how are we really trying to make it better and not make it worse. So before we close, I'd love for everyone to please fill out the survey, just a reminder. I want to very profusely thank every member of the panelists for sharing everything you know, and we're all very grateful, and we'll virtually all clap our hands for your presence. And I also love to invite Professor Brody back to have a concluding remark.
Just wanted to say thank you again to the panelists and to the audience for their great questions, and to just the expertise on the panel. We are so pleased about this, and it's really our goal here to kind of pick up on the last comments to increase education at the intersection of race and technology. So thank you very much.
So as a closing remark, thanks a lot, and thank you for the panelists. And I hope we all, move the needle forward and have some great successes, because we need it soon, and it's very urgent. So thanks, everyone. Have a good night.
Thank you. Bye.